Hello students, this is Mr. Ezra, and today we are going to begin to talk about number systems. So we express numbers in many different ways. We have different types of numbers, which may sound a little weird, but when we in this class are talking about whole numbers or natural numbers or integers or rational numbers or irrational numbers or imaginary numbers, I want you to know what we're talking about. So pay attention, get some notes, and let's get started. We will start with the natural numbers. When we talk about natural numbers, we are talking about like counting numbers. So we would start with 1, 2, 3, and so forth. And we'd keep going up as far as we needed to go. But natural numbers have no fractions. Natural numbers have no decimals. They have no zero. Zero wasn't around when we started using natural numbers. In fact, the only thing that the whole numbers add to our understanding of numbers is the concept of zero. So when zero first hit the scene, it was so revolutionary that we have a whole new name for a number system that includes zero over the natural numbers. So whole numbers would start with 0, and then 1, 2, 3, 4, and on forever and ever and ever and ever. Integers is when we introduce what are called positive and negative numbers. So at this point, not only are we increasing 0, 1, 2, 3 forever to the right of 0 on a number line, but now we also are going to go -1, -2, -3, and so forth to the left of 0. So integers, when we talk about integers, we're talking about essentially positive and negative whole numbers, not just the positive whole numbers. Rational numbers add another layer to our discussion. When we start talking about rational numbers, we start talking about numbers that can be expressed as a fraction. So we're talking about fractions, for example. We are talking about decimals that repeat. So like 0.444444 repeating forever. So we are also talking about terminating decimals, decimals that end like 0.5, 0.7, 0.23. So 0.23 can be expressed as a fraction. The fraction would be 23 over 100. Repeating decimals like 0.4 repeating could be expressed as a fraction. That would be 4/9. And fractions themselves can be expressed as fractions. And in fact, the natural numbers, which are included in the whole numbers, which are included in the integers, are included in the rational numbers. So any integer you can express as a fraction by putting it over 1. 3 over 1 is the same thing as 3, so we could express it as a fraction. We do have some numbers that are not rational. So at this point, let's switch over and kind of realize that the numbers we're talking about now are not rational at all. They are, in fact, irrational, meaning not rational. These are numbers that cannot be expressed as a fraction, that are not repeating decimals, that have non-terminating, non-repeating decimals. Numbers like pi and the square root of 2, or really any square root that is not a perfect square, would be an irrational number. So these types of numbers are on a number line. You've got all your rational numbers. So there's irrational numbers in there too, like pi 3.14159 and on and on and on and on. But we cannot express them as a fraction, so they have a different name. Now, the rational and irrational numbers together are what we call the real numbers. When you think of a number line with all the numbers on the number line, all of the little slashes along the way, all the in between, the whole number line itself is defined as the set of all real numbers. In Algebra 2, we will begin to discuss numbers that are not real. These are called imaginary numbers. Imaginary numbers are how we deal with a negative under the square root. In fact, the square root of -1 is defined as I, which stands for an imaginary number. So if we had the square root of -5, we can't really do any math with this because there's no way to take the square root of a negative number because nothing squared would give you a negative. But If we use the imaginary numbers, we can express it as I times the square root of 5. In other words, the square root of negative 1 times the square root of 5. And now we're good to go. The square root of negative 16, for example, could not be reduced the way that it's written. But if we use an imaginary number, we can say, well, we'll call this negative under the square root and I, and take the square root of 16 to give us 4. So the square root of 16 can be reduced as an imaginary number, whereas it could not be reduced without the imaginary number. So I wanted you to see them today before we get to the part of the course where you will need them. And the last type of number that I have for you today is called a complex number. And all a complex number does is it is the combination of a real number and an imaginary number. So it's like real number plus or minus an imaginary number. I want you to think like 3 plus 2i. There's a real part, 3, and an imaginary part, the 2i. And together, that is what we call a complex number. That is all we have today on our discussion of the different types of numbers. Hope that you were able to get some good notes, and I will see you in class.